Assalamu alaikum wa rahmatullahi wa barakatuh. Viewers, welcome to our channel. My name is Mr. Hassan. Today we are going to be discussing stationary points. In our last video, we have seen how to find the equation of tangents and normals to a curve. So in our today's lesson will be stationary points. So let's consider the equation y equals to 2x cubed plus 5. Okay, so first we have to find the stationary point. Okay, we have to find the stationary points. And how are we going to get the stationary points? First, we have to find the derivative function of the equation y equals to 2x cubed plus 5. So we differentiate. This one now becomes, so we have dy all over dx. So 3 times 2, we have 6x. Then you subtract 1 from the power. So 3 minus 1, that one becomes 2. So we have 6 squared. And the derivative of a constant is 0. Okay? So now our derivative function will be dy all over dx equals to 6x squared. Then we know that at stationary points, you have to know that at stationary points, the gradient dy all over dx is 0. So at stationary points, the gradient is 0. Therefore, 6x squared will be equal to 0. So at stationary points, the gradient is 0. Therefore, we divide by 6. So 6 cancel with 6. Therefore, x squared will be equals to 0. Then we have to find the value of x by finding the square root of both sides. The square root of x squared would be x, and the square root of 0 will be 0. So we have the value of x of the stationary points. Then if you have the value of x for the stationary points, you also have to find the value of y, of y. And how are we going to get the value of y? We have to use the equation. And our equation was y equals to 2x cubed plus 5. But in this case, the value of x is 0. So here we have 2 times 0 cubed plus 5. We know 0 cubed is 0, times 2 we have 0, plus 5 we have 5. So when x is 0, the value of y is 5. Good. And now we have the stationary points as 0, 5. Good. Now we have gotten the stationary point, which is 0, 5. And we know that stationary points, the gradient is always equals to 0. The gradient is always equal to 0. Now, once you find the stationary point, then you also have to find the nature of the stationary point. What do we mean by the nature? We mean if the point is maximum, if the point is minimum, or if the point is point of inflection. Okay, so we are going to see that. So let us see if this point is either maximum, minimum, or point of inflection. So we have to choose. Here we have the value of x for this point is 0. So we'll start with 0. Then we have to choose a number on the right hand side of 0, which is in this case is 1. We also have to choose a number on the left hand side of 0, which will be negative 1. So that those are now the values of x. Then we have to find the gradients of these points on the curve. Then we also have to draw the diagrammatical representation. Diagrammatical representation. Good. Now we have to find the gradient when the value on the curve when the value of x is -1. So we know that our gradient dy all over dx is 6x squared. So we have to find the gradient when x is -1. So here we have 6 times -1 squared. We know -1 squared, that is +1 times 6, we have 6. So this one becomes 6. And the line whose gradient is positive, and the line whose gradient is positive should be drawn like that. Okay? Then when x is 0, the gradient will be 6 times 0 squared. 0 squared, that is 0, times 6, we have 0. So when x is 0, the gradient will also be equal to 0. And the line whose gradient is 0 is horizontal in this case. Good. What about now when the value of x is 1? What will be the gradient? Therefore, dy, so 6 times 1 squared. 1 squared, that is 1, times 6, we have 6. So here now we have 6. Okay, and the line whose gradient is positive, just like this one, that is how it should be drawn. Now, there is one thing that we have to note here. As we move from left through 0 to the right, the sign of the gradient is changing from positive through 0 to positive. Then we say this point is point of inflection. Point of inflection. That is the nature of the stationary point 0, 5. 0, 5. It is point of inflection. Same case, if the gradient changes from negative through 0 to negative. For example, let's assume the gradient is changing from negative through 0 to negative, then also the nature of the point will be point of inflection. Let us see another example. We are told find the stationary points on the curve y equals to 4x cubed plus 9x squared minus 30x plus 10. Hence, you determine the nature of each point. That means if the point is a maximum, minimum, or a point of what? Point of inflection. So let us solve. So we said first, we have to find the stationary points, okay? And for us to get the stationary points, we have to differentiate the equation y equals to 4x cubed plus 9x squared minus 30x plus 10. Therefore, dy all over dx will be equals to, so we multiply 3 times 4, there we have 12 x. You subtract 1 from the power, that one now becomes 2 x squared plus 2 times 9, we have 18 x. You subtract 1 from the power, so 1 minus 2, we have 1 minus, the power here is 1. 1 times 3, 30. We have 30. And then we subtract 1 from the power. 1 minus 1, that is 0. X power 0, that is 1. And the derivative of a constant is 0. So when you differentiate this equation, you are going to get 12x squared plus 18x minus 30. And we know that at stationary points, at stationary points, dy all over dx, or the gradient, is equal to 0. Then we come and say to all of x squared plus 18x minus 30 will be equal to 0. So let's simplify this one. Divide by 6, divide by 6, divide by 6. So 6 cancels with by 6, 1, by 6 we have 2, by 6, 1, by 6 we have 3, by 6, 1, by 6 we have 5. So now our equation now becomes 2x squared plus 3x minus 5 equals to 0. So here we have the equation, and we have to solve the quadratic equation. So we can use so many methods. So in this case, let me use the product and sum method. So the product will be 2 times negative 5, we have negative 10. And the sum will be the value of b, which is positive 3. So we have to look for two numbers. When you multiply, you get negative 10. And when you add, you get positive 3. Good. So those two numbers should be 5 times negative 2. This one gives me negative 10. 5 plus negative 2. This one should give me positive 3. So the two numbers is 5 and negative 2. The two numbers is 5 and negative 2. So we come and say 2x squared. Instead of now writing 3x, we have to write negative 2x plus 5x. Because negative 2x plus 5x will give me 3x. Minus 5 will be equal to 0. So here we have 2x as common factor. So we have 2x. 2x squared divided by 2x. Here we have x. 2x divided by 2x. Here we have minus 1. Plus. Here we have 5 is common here. So we factor out 5. 5x divided by 5, we have x. Minus 5 divided by 5, we have negative 1. Equals to 0. So here now we have 2x plus 5. Since these two are same, we just pick one, which is x minus 1 equals to 0. So this now becomes 2x plus 5 equals to 0. We take 5 on the other side. So 2x will be negative 5 divided by 2 divided by 2. Therefore, x will be negative 2.5. Or x minus 1 equals to 0. We collect items together. So x now will be positive 1. So now we have two values of x of the stationary points. Once we get the values of x, then we have to find the value of y. We have to find the value of what? The value of y by using the equation. So for example, we have y equals to 4x cubed, and x is negative 2.5 cubed, plus 9x squared, and x is negative 2.5 squared, minus 30x, and x is 2.5, negative 2.5 plus 10. So therefore, if you use calculator, then the value of y will be 53.75. So already we have one of the stationary points, which will be negative 2.5, 53.75. So we have one of the stationary points. Okay, we can also find the stationary points, the value of y when x is 1. So here we have 4 into bracket 1 cubed plus 9 1 squared minus 30 times 1 plus 10. Again, when you use calculator, the value of y here now becomes -7. So the other stationary point now becomes 1, -7. Good. Now we have the stationary points. We have the stationary points. So the first point is -2.5 and 53.75, and the other point is 1, -7. Good. Now once you find the stationary points, then the next step that you have to go or to do is to find the nature of these points, whether these points are maximum, minimum, or point of what, or point of inflection. So we will start with this point. We'll start with the point -2.5, 53.75. So let us check whether this point is either maximum, minimum, or point of inflection. So we'll start with the -2.5. So we have to choose a point on the right of -2.5, which will be -1, and a point on the left of -2.5, which will be -3. So those are the values of x. Then we have to find the gradients when the value of x is -3, -2.5, and -1. Also, we need to have the diagrammatic representation of the gradient. Diagrammatic representation of the gradient. Good. Now we have to find the gradient when the value of x is -3. And remember, our gradient was dy all over dx to all of x squared plus 18x. So here we have our gradient function. So we have to find the gradient now when the value of x is -3, which now becomes to all of into bracket -3 squared plus 18 times -3 minus 30. So when you use calculator, gradient here now will be 24. So here we have 24. When x is -2.5, the gradient obvious is 0, because this is now the value of x for the stationary points. Now what about when x is -1? So we have to all of -1 squared plus 18 -1 minus 30. Again, when you use calculator, the gradient now becomes -36. Okay, so for the diagrammatic representation, when the gradient is positive, we said that is how the line will be. When it is 0, horizontal, and when negative. So as you can see now, the sign of the gradient changes from left positive. As you can see here we have positive 24. So it changes from positive through 0 to negative. So if you find the gradient changes from positive through 0 to negative, then the point we say is maximum point. Is maximum point. And good. So we are done with the first point. Let us see how we can find the next point, which is when the point is the other section point is 1, -7. So let us see whether this point is also a maximum, minimum, or point of inflection. So we have to start with the value of x of the stationary point, which is 1, and then we choose a number on the right of the value of x, which is 1. So on the number on the right will be 2, and the number on the left will be 0. So here we have the values of x. We also have to find the gradient. And the diagrammatic representation of the gradient. Good. Now, our gradient function was dy all over dx equals to all of x squared plus 18x minus 30. So when x is 0, this one becomes 0, 0. So here we have negative 30. So when x is 0, the value of the gradient will be negative 30. What about when x is 1? So we have all of 1 squared plus 18, 1 minus 30. So since we know this one is the stationary point, the value of the gradient will be 0. What about when we have the value of x is 2? So all of 2 squared plus 18 times 2 minus 30. So here we have 2 squared, that is 4 times 12. There we have 48. 48 plus 36 minus 30. So here we have 48 plus 36. We have 4. We have 84 minus 30, which will be 54. So if the gradient is negative, then the line should be like that. That is how the diagrammatical representation when the gradient is negative looks like. If it is 0, we say it is horizontal, and positive, that is how it will be. Good. Now from here we can see that the sign of the gradient is changing from negative through 0 to positive. The sign of the gradient is changing from negative through 0 to positive. Then we say this point is minimum point. So if the sign changes from negative through 0 to positive, then the point is minimum point. So that is how you are supposed to find the stationary points. That is how you are to tell whether the points are maximum, minimum, and points of inflection. So we'll stop there, our lesson today. I wish you all the best. Make sure you subscribe to our channel so that we'll be recording more videos so that you can benefit while you are at home. So always, I wish you all the best. Bye-bye.